Hello everyone. Welcome to Besmile webinar. My name is Shaw, and I'm the dental technician and engineer from Besmile. I'm very glad to be here to meet you all. Today, our topic is from trouble to confidence. 3D Master tips every technician needs. So, from this webinar, I will share some technical tips or skills about 3D Master to make you more confident to use 3D Master. Okay.
I will not translate, only if I think that it's something important. I will not translate, so you can do it step by
Okay.
step, okay?
No problem. Mhm. And here are the contents of the webinar, including four parts. First part, 3D Master, next generation multilayer zirconia. So in this part, I will give you an introduction. Second part, master key techniques of the 3D Master. And third, the crack prevention and fixes. And fourth, the shade troubleshooting. So now let's start from the first part, 3D Master next generation multilayer zirconia. As we know, 3D Master is upgraded from the SHT ML, and it is a latest generation multilayer zirconia. We utilize the latest zirconia powder to do the upgrading for better performance. It has the optimal strength and translucency. Translucency is from 43 to 51%. The flexure strength from 800 to 1200 megapascals. And the fracture is more than 5.8, which can ensure the long-lasting durability of the restorations. Based on the traditional multilayer, we explore the new multilayer technology, interleaved layer structure on the 3D Master. With this spatial structure, 3D Master can achieve seamless gradients in shade, strength, and translucency. You can see that on the left side is a traditional multilayer. In the traditional multilayer, there are some obvious boundaries between the layers, but on the right side, in the 3D Master interleaved layers, the transition is smooth. And this slide is a patent certification of our core technology. Our exclusive zirconia layering technology has obtained the US invention patent authorization. This patent is the core competitiveness of our zirconia products, guaranteeing the aesthetic strength and durability of our products at the technical level. We analyzed the conventional multilayer structure by using the scanning electron microscope. Non-uniform grains transition at the interlayered interface leads to stress concentration, pores, and micro cracks in the bonding region between adjacent layers, which is the root cause of the lower interlayered strength compared to the individual layers. We can see that these two pictures shows the structure of the traditional multilayer and 3D master under the scanning electron microscope. In the traditional multilayer, there's the obvious boundary between the two layers. We can see on the left down picture, this is a scan electrode structure of the traditional multilayer, and you can see the grains of the cornea. On the right side of in this picture, on the right side, you can see there are some small sizes of the grains. On the left side, there are some bigger size of grains. So there's a boundary between the big and small grains of the cornea. But on the right down picture, it's a scanning electron microscope structure of the corneal 3D master. You can see that the big and small grains of the cornea are mixed veil. So there's no obvious line. So that's why uh, we have the seamless gradient in the between the layers. The deformation during sintering and the fitness of the lump bridges are also very important. Our new product has low deformation, which can ensure more accurate and comfortable placement. More uniform shrinkage during the sintering process leads to more predictable and reliable outcomes. So you can use it to make lump bridges and full arch without crack, which can lower down your return jobs and save your cost. For labs, zero deformation can minimize the fracture risks, lower the remake rates, and save more time and cost. For clinics, there's no need for adjustment because we can achieve 1 second precision fitting to provide more convenient for doctors and more comfort for patients, more efficiency for clinics. Okay, so now we finished the first part. The second part is about the master key techniques. The disc design of the 3D Master is 6-layer structure to ensure more smooth gradient and natural transition. And it is cam friendly because of the dentin layer is up to 40%. So you can see on the left side, this is a layer distribution. You can see the incisor layer 20% and 2 transition layer and dentin layer and the 3rd transition layer and cervical layer. The dentin layer is up to 40%, which can allow you to nest different sizes of crowns in the same disc. And in this chart, on the right down area in this chart, you can see the layer height of each layer in different thickness of the discs. For example, let's take the 12 millimeters of the cornea, for example. The incisor layer, 2.4 millimeters. The dentin layer, 4.8 millimeters. So the dentin layer is almost the biggest part in the total layer height. And for the nesting of 3D Master, if you use our mini machine, you can put the boundary of the teeth out of the disc, so you can mill more crowns and save the material. Because you know, for our dry milling machine, we have the quarter clamp. So 3/4 of the fixtures are open. And in this area, you can move the boundary of the crowns out of the disc to save the materials. And if you want high aesthetic, or to say high translucency, so you can move the teeth upwards in the z-axis direction. You can move the teeth upwards within the disc to put the crown more in the incisor part to get more translucency. If you are nesting a big bridge for full arch, we recommend you add the sintering stabilizer. And the type of the sintering stabilizer, we recommend this type. You can see it's like it's a hollow sintering frame. And the thickness of the stabilizer is 1.5 to 2 millimeters. So if the thickness of the bridge is bigger, we can increase the thickness of the stabilizer according to the thickness of the bridge. The new multilayer has a flexible sintering range from 1520 to 1560 degrees. Within this range, it can give you stable, reliable outcomes every time. So you can, for example, you can see here are the sintering results, 5 crowns sintering results at different temperature. 1520, 30, 40, 50, and 60 degrees. So you can see that the shade are almost the same. The only difference is that if the temperature is a little bit higher, the translucency is better, but the shade always keeps the same. And our 3D Master can support 3-hour fast sintering, including the cooling time. And this slide shows how can we make sure our cornea 3D Master give you consistent, beautiful results. First, we start with high quality raw materials, checked with more than 20 quality control steps to make sure they are perfect. Then we follow the ISO standard during production. This is a strict global rule for the medical products. So every step is safe and reliable. After production, we pack the products carefully, and the final product is certified by CE, FDA, and NMPA. So you can see that we control the quality from start to finishing. So you can always get great, consistent result. And proven by many tests, we can finish full arch sintering in just 10 hours, which can save the time. And the curve here is the standard sintering curve for our 3D Master. You can see totally 605 minutes. And there are 2 stages, 900 degrees for holding 10 minutes and 1530 degrees holding 150 minutes. And this curve works this curve works for the restorations from 1 unit, single unit to 14 units. We also have our fast, rapid sintering solution. We can finish sintering in just 3 hours, which is a huge time saver. And this delivered 70% efficiency improvement compared to the standard sintering. So your lab can work more faster. And so far, we have launched 2 models of furnaces for both fast and standard sintering. They are FM30 and FC30. And here's the comparison of the 2 models. They have some same features. The difference are about the heating element, capacity, and the speed. If you have a big lab and have a big quantity of teeth to sinter every day, we recommend FM30 because the big capacity. So in one cycle, it can finish 60 to 80 units of crowns. If you have a clinic and want to deliver the final restorations as soon as possible, we recommend FC30 because the ultra fast sintering speed. The maximum speed of FC30 is 100 degrees per minute. And the heating elements for FM30 and FC30 are different. The heating elements for FM30 are molybdenum disilicide rods, and they are connected in series. The heat elements for FC30 are silicon carbide rods, which are connected in parallel. So if one rod is broken, the FM30 cannot hit him because the circuitry is broken. But for FC30, if one rod is broken, the furnace can still heat, but it cannot reach the temperature it is supposed to be. Because there's only 3 heating elements are working. Okay. And this is the technical data. You can see flexural strength, translucency, and the shade we can provide. The shade we can provide the Vita 16 shades and the OM1, OM2, OM3 bleach shades. And here I would like to show you some cases made by 3D Master. And you can find the best balance between the aesthetic and functionality. And this is a full arch made by 3D Master after glazing. This is a 3-unit bridge. And these are single crowns. As you can see, it is the 3D Master is one for all materials, which covers all the indications from single unit to 14-unit bridges. And here I want to ask post a question. Have you ever been struggling with inventory overload? I think it's a common lab problem. Too many materials and complicated stock management waste your time and money. But you don't need to worry about it anymore because we are here to show you a better solution. As is known to us, there are some common zirconia shades, including A1, A3, B1, C1, D2. So for the common shades, many labs they buy many pieces, so they are usually in stock. But for the uncommon shades, no one will buy a lot of. So once they run out, there's a problem that you cannot deliver the teeth on time. When the shade you need is in stock, the process is simple. Just from the lab to clinic to patient. The patient only wait for 1 week to get their restoration. But when the shade is out of stock, everything changes. The supply chain becomes extremely long. Lab to dealer, to manufacturer, to dealer, to lab, to clinic, to patient. That means the patient has to wait 1 month or more, which creates huge delays and pressure for everyone in the chain. This is a common pain point for labs and clinics, and it directly impacts patient satisfaction. We started with a full Vita 16 shade guide, analyzed its color system, and selected the 5 most used shades: A1, A3, B1, C1, D2 to meet most daily patient needs with fast, reliable stock. You can just keep 5 shades of 3D Master in your inventory because you can apply 5 dentin shades of atomic stain and glaze kit on the 3D Master to reproduce 16 classic Vita shades. Like this presentation, like this slide shows. 3 3D Master shades plus 5 3D Master shades plus 5 atomic shades, then you can reproduce 16 Vita shades as desired. For example, we start with A1 and A3. So there are two A1 crowns and 2 A3 crowns, and the target color are A1, A2, A3, and A3.5. So how can we reproduce? For the A1, we just need to brush 1 layer of glaze on A1 crown. For the target A2 shade, we can brush 1 layer of shade A on the A1 crown. For the target color A3, we can brush just 1 layer of glaze on A3 crown. For the target color A3.5, brush 1 layer of shade A on A3 crown. And here's the convention table from 5 to 16 shades. So you can find you just need to keep 5 colors, A1, A3, B1, C1, D4, and by brushing the different dentin shades, shade A, shade B, shade C, D3, D4, with different numbers of coating. So from A1 to A2, you can brush just 1 layer, but if you want to make A3 to A4, you need to brush 2 layers. And we provide different atomic kits for you to meet your needs and give you the endless possibility. Sorry. If you are a new user and want to just have a try on our standing, you can test the starter kit, which includes glaze, shade A, and blue shades, and one blending liquid. If you want to do the staining on the implant cases, our gingiva kit is suitable for you because there are 8 different gingiva colors, including 3D gingiva colors to mimic the natural gingiva structures and colors. We also have our ultimate all-in-one solution, atomic master kit with a full range of stems, glaze, and liquids to cover every possible aesthetic cases. There are totally 18 colors in this atomic master kit. Okay, until now we finished the part 1 and part 2. So now let's come to the part 3, crack prevention and fixes. Actually, it's a fracture troubleshooting and some tips and suggestions to prevent the cracks. So first, I want to show you some fracture cases. The first case is a long bridge with a sintering frame, but just after sintering, the customer found there's a crack. There's a crack. Could you see my mouse? You can see here I circle. There's a crack. It's not obvious. Only on the strong light we can find this crack. Okay. So later I will explain why this happened. So you may meet the similar situation, similar crack issue when you make the long bridges. So now let's just hold the question. And after the introduction of this part 3, I will explain why this happened. Okay. And the second case is also a long bridge, a full arch with a center frame, but the crack position is different. So for this bridge, it cracked at the connectors between the bridge and the stabilizer. So you can see it cracked on the connectors. Some customer may say that the crack appear not on the crown, not on the bridge, just on the connectors. Can we use the bridge as normal? The answer is not, because even the crack is not on the bridge, it's on the connector, but the bridge has already deformation during sintering, so you cannot place the bridge smoothly on the model. So there's maybe a not fit on the model. So if you make it fit with force, it's easy to make the bridge broken. Okay. So the crack. So next step, I will explain how can we prevent the cracks in the different manufacturing steps. Actually, the cracks could happen in every manufacturing step, but most of them happen after sintering or when teeth placement in clinic. And there are some suggestions or precautions in each step to reduce the risk of crack. So first, for bridges, we must make sure all the prepared teeth should have the common path of insertion. Only in this way, uh, the restoration will have a perfect fitting. Otherwise, the bridge uh, cannot be settled on the model. And if the teeth are not prepared well, there will be some undercuts. When we design a restoration on these teeth, when we design the restoration on this teeth, on this abutment teeth, for this area, you can see my mouse, I put my mouse. For this area, the restoration has no support from the natural teeth. So when it is used in patient mouth, it will lead to stress concentration. And after the use of a period of time, it may crack from this area. So if we find there's undercut, we have to discuss with the dentist about this issue and the risk of crack if he doesn't re-repair the teeth. If he doesn't re-prepare the teeth. So the best solution is to prepare the teeth without undercut. But sometimes we cannot persuade the dentist to redo it again. So in this case, we need to make the dentist aware of the risk of crack. The next one is the occlusal cervical dimension. In other words, the height of the abutment teeth. If the height is not enough, it cannot provide enough support to the restoration, and it has no enough bonding areas. So it has a high risk of falling off. For the anterior and premolar, the height of uh, the abutment teeth is supposed to be more than 3 millimeters. For the molar, it is more than 4 millimeters. And next point is the successive pontics and distal pontics. There are, sorry, if there are so many successive pontics or distal pontics, the residual teeth cannot provide enough support to the long bridges. And on the other hand, it also will do harm to the residual teeth, residual natural teeth. The successive pontics should be less than 2. The number of the successive pontics should be less than 2. So you can see that I give two examples, two pictures here. On the left side, this green circle area, there are 2 successive pontics. It's okay. It's acceptable. Or to say the length of the successive pontics should be less than 30 millimeters. Sometimes the customer will design the lower arch. So for the lower arch, because the size of the crowns are smaller, so it's more flexible. So maybe they can design with 3 or 4 successive pontics. Just make sure the length is within the length of the successive pontics is within 30 millimeters is okay. And for the distal pontics, the maximum number is 1. So if there are 2 successive pontic, sorry, if there are 2 distal pontics, it's not acceptable. It's not acceptable. So we should avoid this kind of design on the right in the right side picture. Okay.
John, just a short reminder, doar o scurtă reamintire. Dacă aveți întrebări din prezentare, vă rog să le scrieți pe chat. Cine se descurce cu chat-ul, dacă nu, la sfârșit o să luăm și parte de voce, dar ar fi mai simplu în chat, dacă le scrieți în română sau engleză și eu le voi traduce la sfârșit, la sfârșitul prezentării. Mulțumesc. Ok, we can go further.
Okay. And next point is about the margin lines and round and shoulders. So all the prepared teeth should have clear margin lines and round shoulder. In the left pictures, you can see the shoulder, the margin line is clear, but on the right side, you can see the margin line is not clear, so it's not good for the restoration. So only with the clear margin line and round shoulders, which can ensure the fitness and uniform force distribution to avoid the risk of fracture. And next point is about the edges and the round edges and the reduction depths. So the sharp edge, sometimes the sharp edge usually happens in the anterior region. All the teeth should have the round surface, as you know. The minimum burr of the minimum machine to mirror the cavity of the crown is 1 millimeter. So if there's a sharp edge, so if the cavity, the incisor part of the cavity is sharper than 1 millimeter, the milling tools cannot get to that position and mirror that area. So this could make the restoration not fit on the model. And if we do some manual adjustment in the cavity, the thickness will be smaller than required. Sometimes it will be smaller than required. So it's easy to fract from this place. So for the anterior teeth, the minimum reduction, the minimum size of the incisor part is 1 millimeter. And there are also some requirements about the thickness of the reduction. So for the incisor part, the reduction is supposed to be more than 1 millimeter, from 1 to 1.5. And for the cervical part, at least 1 millimeter. And for the posterior crown, when the dentist prepare the teeth, they need to make sure the enough reduction depth on the occlusal side, on the occlusal central forcer. And we recommend open angle here, you can see, from 120 degree to 140 degree to make sure the reduction depth of the occlusal side is consistent. And when we are design, we also need to make sure the enough thickness of the restorations. No matter what design software you use, 3Shape or EXOCAD or some other type of designing softwares, we have to make sure the thickness is at least 1 millimeters. And this is a requirement for the full contour crown, full contour restoration. If you are making coping bridge, we need to make sure the thickness is at least 0.5 millimeters. And when we design the connectors between two crowns, we should pay attention to the size. We should pay attention to the cross section of the connectors. For the anterior teeth, the connector crossing area should be more than 9 square millimeters. For the posterior, connector crossing section area should be more than 12 square millimeters to ensure enough strength of the connectors. Okay, and when we design, in the designing software, there's a parameter called anticipate milling. So we also need to check if this uh, parameter is set correctly. So generally, the value of the anticipate milling should be more than 1 millimeters. So we recommend the value is like 1.1 or 1.2 millimeters to ensure the design crown has no sharp cavity to make sure the mini burr can mill out the incisor part. Okay. And the third point is about the sintering stabilizer for the long bridges. So for the long bridges, we recommend to add a sintering stabilizer when nesting. Otherwise, there will be a high risk crack or to say the uneven deformation. And we recommend to set this type sintering frame, this hollow sintering frame with 1.5 to 2 millimeters wall thickness. If you want to save material, you can mill a crown uh, at the area in the middle of the sintering frame. You can mill one single crown. And as for the position of the connectors, we recommend to set the connectors on the height of the contour between the middle one-third area. And set 6 to 8 connectors evenly distributed on the left and right side. And next part is about the coloring. So if you use 3D Master, if you use multi-layer blocks, generally you don't need to do the internal coloring. But if you use the precious blanks, white blanks, you have to do the coloring before sintering. We need to after we do the coloring, we have to dry the restoration. If we don't dry the restoration for enough time under enough temperature, the risk of the crack will be much higher because the residual coloring liquid will influence the shrinkage and the transformation. So to avoid this problem, we need to make sure the drying time is enough. We can use this inter use this light or this kind of oven to dry the restoration. If you use a light, we recommend the distance between the restoration and the light is 90 millimeters. If you use the oven, we recommend you to set the temperature from 90 degrees to 100 degrees. And for the single unit and small bridges, the drying time is like half an hour, 30 minutes. And the longer the restoration, the longer, the bigger the restoration, the longer the drying time. So for the full arch, we recommend the drying time is more than 60 minutes. And as for the sintering process, we should use the standard sintering curve from the uh, manufacturer. The most important is the heating rate or cooling rate. You can see that in the standard sintering program of our 3D Master, the heating rate is like 3 degrees per minute, and the cooling rate is 5. If the heating rate and or cooling rate is too big, there's a risk of crack or deformation during sintering. Another thing that we need to pay attention uh, is the temperature when opening furnace. You can see the program finishes at 800 degrees. After that, it's natural cooling. If we open the furnace at a high temperature, the restoration will suddenly expose to cold air and lead to crack easily. So we recommend the open temperature should be lower than 500 degrees for the single unit and small bridges. And for the long bridges and the full arch, the opening temperature of the furnace should be lower than 300 degrees. And there's one more thing I want to explain to you to avoid the restorations exposed to cold air. Sometimes in the room of the sintering, there's a uh, air conditioner to uh, keep the room cool, especially in the summer. In when the temperature is high. So when you use a air conditioner, we need to avoid the cooling air blowing direct to the restoration, blowing direct to the furnace. Because if the um, if the cooling air blowing direct to the restoration, there's a uh, sudden sudden cold to the surface of the restoration, but the internal of the restoration is still very hot. So there's a uh, big difference, temperature difference between the inner structure and outer structure of the crown, and it will has a high risk of broken. And when we grind the cornea after sintering, there's also something we need to pay attention. When we grind, it will generate a lot of heat in the grinding area. So we need to do cooling during grinding. We need to prepare a bottle of water, and we before we do the grinding, we can immerse the restoration in the water, and then take it out to grinding. So on the grinding area, the temperature won't be that higher. And after the restoration get drier, you can immerse it into the water again. And in this way, you can cool the restoration wheel during grinding. And the rotation speed of the grinding machine recommend from 20,000 to 25,000 revolutions per minute. And the method to grind is one direction. One direction is better with light pressure and one direction. Okay. Another thing that we need to pay attention to is uh, the finishing opening temperature and the finishing heating rate and cooling rate. So for the long bridges, the heating rate and cooling rate of the glazing sintering should be more than 40 minutes, 40 degrees per minute. And for the single unit, you can set like 50 degrees per minute or 55 degrees per minute. It is no problem. But for the long bridges, we recommend you to set it lower heating rate and cooling rate. And the opening temperature also it's 300 degrees. And sometimes uh, the technician need to do several times of firing, several times of sinterings. One for veneering and one for glazing, or maybe one for staining. But with the increasing of the firing times, the risk of fracture, the risk of crack will also increase. So we suggest for long bridges, uh, no more than 3 times of firing for the same bridges. Okay, so now let's come to the last part, shade troubleshooting. You probably meet some shade problems or translucency problems when you use multilayer blocks, such as poor translucency, inaccurate color, and polluted color. So here, I would like to explain the reason for this shade and translucency problems and the solutions. How can we avoid or how can we solve this kind of issue? So first, we need to know that the thickness of the cornea directly affect the final colors and translucency of the restorations. On one hand, No matter is a Vita sheet guide or Ivoclar sheet guide, the sheet guide is standardized for 1 millimeter thick zirconia. So, for example, when we compare the 1 millimeter thick zirconia to the 1 millimeter thick of A2 zirconia to the A2 sheet guide, if the shade uh, is matched, we can see that the shade is accurate. You can see that shade is accurate. But as the thickness increases, the restoration appears darker and the translucency appears lower. For example, if you use the 2 millimeter thick the cornea to compare to the A2 shade guide, the actual shade of the restoration could be darker than a little bit darker than the shade guide. But we cannot say that. We cannot say it's the shade is not accurate because the thickness make it darker. If we compare 1 millimeter to the shade guide, the shade is accurate. So if you want to make some very thick restorations, especially for especially the implant bridges, in general, they are very, very thick, like 2 or 3 millimeters thick. So in this case, we recommend you to use a lighter shade to make the restorations. So after sintering, the shade will be more close to the target color. For example, if you want to make A2 implant bridge, we recommend to use A1 multilayer zirconia disc to make this bridge. So because of the thickness is higher after sintering, the shade is close to A2. Okay, and another factor that affects the shade and translucency is the sintering temperature. Generally speaking, the high temperature causes lighter and higher translucency. So if you want lighter shade or higher translucency, you can increase the temperature by 20 degrees. If you want darker shade, you can decrease the temperature by 20 degrees. So from our test, if you decrease the temperature, if you change the temperature by 30 degrees, if you decrease it or increase it by 30 degrees, the shade, there's a half degree of the shade change after your sinter is crown. For example, if you increase the temperature by 30 degrees, after sintering, the A3 crown might be changed to A2.5 crown. So the shade will be between A2 and A3. Okay. So in this way, we can adjust the shade a little bit as we want. And the real temperature of the furnace will also affect the final sintering result. So it's very important to calibrate the temperature accuracy of the furnace because uh, real temperature in the chamber could be different from the setting temperature you set in the curve. For our FM30, it's easy to calibrate the temperature. There are 4 steps to calibrate our FM30 or to say FC30 sintern furnace. Step 1, we need to run the standard sintern program uh, to sinter the test ring. We cannot use the fast sinter program because fast sinter program cannot get the accurate result. And after sintering, uh, we need to measure diameter of the ring with a digital caliper, as this picture shows. And we can twist, we can rotate the ring to measure it in different direction to get several measurement result and get the average value. And after that, you can find the ring temperature reference table and this table. According to the reference table, you can find the real temperature. For example, if the ring diameter is 19.35 millimeters, you can find 19.35 millimeters. And the matched temperature is 1540 degrees. So the real temperature we tested from the ring is 20 degrees higher than the setting temperature, for example. The program we said is 1520, but the test temperature from the reference table is 1540 degrees. So the real temperature is 20 degrees higher than the program set temperature. So how can we calibrate the temperature to make them match? So first, we just enter the function and then choose temperature calibration. And here you can see there's a compensation value for the temperature. So if the real temperature is higher, you just need to decrease this value. If the real temperature is lower, you just need to increase this value. So for my example, the real temperature is 20 degrees higher. So here you can minus 20 based on 0. So you can use minus 20 to replace the current 0 compensation. And then you can finish the temperature calibration. And sometimes the customer may meet some special shade problems like the polluted color, like the greenish or yellowish or reddish color. So this special shade problem might be caused by the impurity of the center furnace. So we suggest the customer to purify the sintering chamber to sinter the leftover materials to absorb the pollution. So in our furnace, there's a cleaning program. The customer can just use the cleaning program to sinter the zirconia leftover materials. It's better if you can use the white blanks because the white blanks after sintering is supposed to be white. If there's some other colors like green or yellow colors, which means that uh, the chamber of the furnace is polluted. So in this case, you need to uh, use this leftover material to uh, purify the Sichuan chamber several times until the result appears white. So for the customer who only use the multilayer blocks, they can do this like every month or every 2 months. But if the customer use many colored restorations, if they use white blanks more often, they need to do uh, they need to clean the furnace more often. Okay, so that's all for today's presentation.